Hey everyone, so in this video we are going to begin to add enemies. So what we're going to do is first you need to create a 3D model. I made this in 3D Builder. You can use whatever you want and there's absolutely nothing special about it. There's no controls attached, it's just a 3D model. What we're going to do, we're going to have the GM script be made aware of this 3D model and spawn it on a timer. And then this blob object will get its own script that then controls its movement. And basically it's just going to use a random number generated to decide is it going to fall left or right, left or right. That's it. Okay, so let's get into that. So first thing we're going to do, we're going to open up the game flow script. And up here, we are going to make the GM object aware of the blob by doing this. Public transform, and we'll call it blob obj. Now, I like to use the suffix obj when I'm naming objects. That way I know when this shows up in a list that this is specifically an object, because particularly when project gets longer and you have more and more variables and methods and things like that, you really want to make sure you can distinguish the naming. So now, right now this is just an asset. We need to turn it into an object. So we're just going to drag it into the environment, and there it is. We can kind of just move this so we can see it. So this, just like the other 3D object, I had to shrink substantially. Depending on what modeling program, you might not have to do that, but if you do, I just want to throw that out there. So we're just going to rotate this 90 degrees. Nope, negative 90. And because it doesn't really have a front, we don't have to worry about rotation. It's going to look right no matter which direction it drops in. Now, in QBert, this is animated. We can look at animation later. Again, this is just about how you spawn the object, and you have the object have basically give it rudimentary pathing. So we have our object, and now what we're going to do, we're going to take this and we're going to put it down here back into the asset area. We're going to create a new prefab. Going to delete the one that's in the scene. And so what happens is this one is the one that's going to be spawned. And we're actually going to add a few things there. We're going to add a script, like I said. We can always do that after the fact. We don't have to do it before we create the prefab. So we have our object, and we want it to be able to be spawned. So we go back to the GM object. There's the blob object. We just take blob and put him there. And then what we do, we are going to create a timer so it gets spawned at a certain consistent rate. And what we're going to do is we'll use a variable for the amount of time, at least eventually. That way, as levels progress, you can simply shorten the time in between them being spawned. So how do we do that? Well, we already looked at IEnumerator, so just creating another IEnumerator. And this one will be spawn blob. And even though it's underlined, there's nothing wrong with it. It's just saying that there's nothing in here. So now what we're going to do, we're going to do very similar to this. So yield, return, new, wait 4 seconds, and we'll just do 3 seconds. But like I said, we're eventually going to replace this with a variable. That way it spawns faster and faster. So we now need to instantiate an object after the 3 seconds have passed. So when you hear instantiate, that's the command to spawn. So when you hear instantiate, think spawn. We're going to spawn the object. So instantiate, 3 arguments. What's being instantiated, which is the blob obj. where it's being instantiated, we're going to instantiate it. This too could be a variable because you may want it to spawn in different places. You might want it to spawn up here. You might want it to spawn here, here. I guess we'll just do the top. So what we'll do is we will have the spawn above 0, 0, 0. We'll have it spawn like just above it. So this is also a vector 3. So we just said 0, and we'll do like, say, 0.5 F, so it's just above that tile. Actually, no, we want it to actually drop down from above, so let's do like a full 2 above it. If you use a decimal, you have to drop an F to let them know it's a float. If you're using a whole number, you don't have to do that. And so that's the second argument. So again, what's being instantiated, where it's being instantiated, and then the rotation will use the blob object's own rotation. So instantiate the blob object at 0, 2, 0. And now that we've created this, we need to call it, because just as in the update section, we need to call this one, we also need to call this one. So we're going to do it outside of the if statement, of course, though, because it's not dependent on remaining tiles. We just want this to be done every 3 seconds. So let's actually put this in the start section, because this would be, even though there's a 3-second delay, if we put it here, this entire section gets run every frame, which means every single frame it would be doing this again and again and again. So let's actually put this in the start section. So let's do start coroutine, and this will be spawn blob with parentheses and a semicolon, not an apostrophe. Sorry about that. And then what we do, we go back to our scene, we go to our blob, open prefab, and now we're going to start adding a few components. Right now it doesn't have a rigid body, so it would just spawn up there and do nothing. Can use the default settings. We want gravity to be applied. We might eventually freeze the rotation. We'll see. So let's run this. Let's just move him. Okay, so it dropped, but it went through it. That's because it does not have a collider. So what we do, we go back to our blob, and we go back to that, and we add component and physics, and we're going to add a box collider. So what we do, I'm going to edit this collider. And you don't have to use a box because it's roundish, but for our purposes, this is fine. It's not using really precise. So I could lower that bottom a tiny bit. Okay. So now it has a box collider. So now when it lands there, it'll stop. So let's bring him down. Perfect. Now, obviously, we don't want it to change the color. We mentioned that in the previous videos that we're going to have to put a control in place that right now the tile changes unconditionally, that if a collision happens, it changes. Now we're going to have to check for what's colliding with it, which is fine, but let's get the pathing done first. I don't want to get distracted by that. So for the pathing, as I said, we're going to add a script to this object that controls it moving left and right. Just like QBert, the difference is it'll be automated. So let's right-click, create C# and we'll call this blobcon. I'm not sure if I will use the same script for the other enemies. That's why I'm making a script specific for the blob. Sometimes you have different enemies that they appear differently, but they move the same, control the same, so you can use the same script. Don't think that's the case this time. Because the blobs don't chase. Again, they're just kind of tracking down like a slinky. So we're going to, again, click on our blob object, open prefab, give it that blob con, and then what we're going to do, we're going to use movement that's basically identical to what QBert does because it's a very fixed location movement. It's not as we discussed, it's not like a regular 3D game where you can run around in little minute controls or little minute increments that you're having a very fixed location you're moving to. So right now we use -90, 0. Sorry, that's the angle. My apologies. We're using 0, 4, -1. So for it to move down along the left, this is what we need to replicate. So let's just actually copy that. So we go to blobcon, and we don't want this to happen as soon as we want this to be based on a collision. We don't want it to happen as soon as it's spawned. So what we'll do is, again, we'll do on collision enter. And again, we get rid of the word collision here because it looks like it's a functional word when in fact it's referring to the other object. So what we're going to do is when the blob collides with something, it will then move. And that automatically gives you your timing. Now, it's possible you may not like that. It's possible that you say, no, I want it to kind of hover for a bit so we can look at putting in a delay. But again, it's an iterative process. You start with the basics and then you build on it. So this means that when this blob, so the blob will be instantiated, and when it collides, and the first collision will be the top tile, it'll then start jumping down. Because this will keep happening. Every time there's a collision, it will jump again. So you don't even have to, like I said, at the moment there's no timing. It's based purely on collision. So there's no pause or hesitation. If I haven't forgotten anything, that should actually, there's no randomization. It will always drop here and always come down here. Let's see if I made any mistakes. Okay, he's kind of rolling around. Not great. So what we're going to do is we're going to constrain the rotation as I mentioned a few seconds ago. You might like that effect of how it's spinning around for a different game, or maybe even this game, maybe you just want like garbage that's falling, some kind of debris. The physics is doing the work for you. So we go back to our prefab, and what we do is we freeze the rotation. Sometimes I'll edit out mistakes like that, but this is a good example of demonstrating why you use these. So you have that controllability over the rotation. Just like that, it works. And then someone asked me in the comments how I'm going to control the out of bounds movement. I might just put a collider box underneath the entire map, and then if anything hits the collider box, it gets destroyed. But just like that, you've added a rudimentary pathing system. So you now have an enemy and there's a pathing system. Again, there's a couple things we have to be mindful of. We eventually want it to not change this, which should be a simple if command. We just need a way to differentiate between which objects, so we may actually lean into tags like I mentioned in a couple of videos ago. Now what we do, so right now only a single object gets instantiated, and that's controlled by the game flow script because it says start. In the start section, which happens when the GM object gets instantiated, which is when the scene starts. So this only runs once. So what we need is we need this to happen over and over again. So what you can do, I believe the term is auto-recursive. You can have this look at itself. In other words, it waits 3 seconds, spawns the blob, and this says, okay, start all over again. So it points back to the beginning. And just making that one change, having the delay itself look at the delay. And there you go. I get it. It's nice to see something really come together like that. Now, really, all of that remains, as far as the pathing, is to determine is it going to fall right or is it going to fall left. And the other thing that we're going to do is make sure that it doesn't change the tile when it lands on it. So let's now go back to the scripts. And what we're going to do is right now we, on the blob conscript, simply say that when a collision occurs, do this. So what we want is we want there to be an if statement that looks at a random number and then says, okay, well, based on the random number, does it do this or does it fall in the opposite direction? So the opposite direction, we can just copy this and paste it. You're not going to want to run it like this. But the opposite direction was moving along, rather than the z-axis, it's moving along the x-axis, and it's a positive 1 along the x-axis. So again, we're emulating the movement of QBert because it's a confined, as far as where you can move their fixed locations. Okay, so again, don't run it like this because it's not going to give you what you want. So what we can do is we can do a random number and a brief splice there. Sorry about that. Had some capture issues again. So this is crazy easy. So if random dot range, so that generates obviously a random range. Now you give the outer numbers, so 0, 2. So it's going to choose between 0 and 2, inclusive of 0, but not inclusive of 2. Not quite sure why Unity does that. So this number is inclusive, this one is not. I believe if it's searching for floats, then it is, but for integers, it's not. So that means you have 2 choices, 0 or 1, which is perfect because that's what we want. We're looking at it to fall left or fall right. So if it's equal to 0, and sorry, got to be a double equal sign. So if it's equal to 0, then we want the first one to happen. Else, we want the second one to happen. It is that crazy easy. Just hop them down here. So you can see the second one has already taken a different path. The collision caused the problem, but that's okay. We haven't done enemy collision detection yet, but you can see more and more the board is filling out, so that alone is proof that they are indeed taking different paths. See, he just fell this way and the other ones did not. So just like that, you've added an enemy that has variance to its pathing, and basically just about every dot has been hit, every tile has been hit now. So the only thing that's really left, I think, for this particular lesson is to have the enemies not change the tile. I'm not going to get into collision detection with QBert yet. So How do we do that? And actually, let's wait to the next video for that. I think this video has gone on a little bit, and I don't like making the videos too long. I think people get intimidated when they see the length of the video. So let's cut it here. And what we'll do is we'll look at the handling of what object is colliding with the tiles, what object is colliding with QBert. We'll handle that in all one video, since this was really more about the pathing of the blob. Okay, so let's end it here. If you have any features you'd like to see, please just leave a comment, and I hope that this has been helpful, and have a good day.